Now let's look at kingdom Animalia. And one other thing that I forgot to tell you is we can remember the kingdom uh, phylum, class, order, family, genus, and species, right? These are all the 7 obligate categories. And some of you have even written it down, so very good people. But remember, there is another one, domain. So you can remember that if you put a mnemonic to it, it is dear King Phillips came over for good soup. Mnemonic means the first letter of the sentence. Dear King Phillips came over for good soup. D is for domain, K is for kingdom, P is for phylum, C is for class, O for order, F for family, G for genus, and S for species. Remember that. Dear King Phillips came over for good soup. But if we take the domain off, we have 7 obligate categories. Okay, otherwise we have 8 if we add domain to it. Now, this is the classification that we have learned in our previous class, right? But from domain to kingdom, from domain to kingdom, there are subcategories. Now, what are these categories? We have to learn this, and it is important to know, okay? So we know that there are 3 domains, right? Eukarya, archaea, and bacteria. But we are only interested in eukarya and Animalia. So kingdom Animalia. We're going to go all the way down to, well, not all the way, but phylum. According to the obligate categories or the main categories, we know that in the kingdom we have different phylum. Right, this is one of the kingdoms in eukarya. Anyway, so when it comes to obligate categories, these two are right next to each other, right? Animalia, and then comes phylum, right? There are in 4 and there are 9 in here, right? 9 phyla. Now let's see. Now kingdom Animalia has subkingdom. There are subcategories, okay? So the after kingdom comes subkingdom. Should take another, let's take another color. Subkingdom. Now kingdom Animalia has 2 subkingdoms. What are they? Let's see. One is Parazoa, the other is Eumetazoa. Now we all characterize them because of, we all do the classification based on certain characteristic features, right? So this is the first level, and the tissues haven't formed yet. So this is the organization is cellular level of organization. Because we don't see any tissues here. We have, for the first time, we have a tissue grade of organization in Eumetazoa. Here, for example, you have Porifera. And this is the phylum, right? You know that, right? This is the phylum. An example is Fundus. So kingdom Animalia, we are gonna go from kingdom to phylum with the subcategories. Okay. So the first subcategory is the subkingdom, and it is a cellular level of organization because we haven't the tissues haven't formed yet. So there are parazoa and eumetazoa. In eumetazoa, we see the tissues. In parazoa, you do not see the tissue grade of organization. It has for the first time you see it in here. And the second one is, now this stops here, right? The first phylum, Porifera. So the next one is Eumetazoa. What do we see in Eumetazoa? Now the Eumetazoa also has two grades. One is radiata, the other one is bilateria. Now there it was a cellular level of organization. Now here is based on the symmetry. This one has more than one line of symmetry. For example, if you take, for example, Hydra, you can cut the before we name the animal. Uh, let's take the phylum first. The phylum that are included in the radiata are Ctenophora and Cnidaria. And you see, for example, these are the phylum, okay? And in Cnidaria, for example, you can take as Hydra. If you can cut the Hydra on different planes, there is more than one plane of symmetry here, that's radiata. And in bilateria, you can cut the organism into two halves, bilateral symmetry. This is based on the organization. Here we're talking about the how they are organized. That is how we are classifying or differentiating from kingdom all the way to phyla. So here we see bilateral symmetry. These are diploblastic animals. That means di means two. These are triploblastic. And you see diploblastic is you have ectoderm and you have endoderm. Here triploblastic you have ectoderm, endoderm, and mesoderm. There's a new one here. So there are two grades, radiata and bilateria. They are also called as diploblastica or triploblastica as far as grades are concerned. When it comes to the layers, it has two, ectoderm and endoderm. It has three layers, ectoderm, mesoderm, and endoderm. That is grades. Now below this grade, you have division. So this is again divided into two. That is protostomia deuterostomia. This looks confusing, but if you actually try to understand it, it's pretty clear. Proto means first. Stomia means mouth. Deutero means secondary. Stomia means mouth. What does that mean? See, before we have seen, if we go up, we have seen that there's a cellular level of organization where the tissues are not formed. These are porifera, right? Parazoa and eumetazoa. Example is phylum porifera. Now, in the eumetazoa, the next grade of organization is symmetry. Okay, so that is radiata and bilateria, and they have either 2 layers or 3 layers, diploblastica and triploblastica. Now, the third organization is based on cleavage. Based on cleavage, or you can also say developmental stage. Usually the embryo developmental stages. So what's the difference between these two? How did they differentiate between protostomia and deuterostomia? Now, as the name itself indicates, proto means first and the deutero means secondary. So when in the blastospore, there is a, how do you explain it? There's a blastula state, there's a blastopore, right? Here in the protostomians, it becomes the mouth. But here, it becomes the anus. The mouth is secondarily formed at the opposite end of the anus. This is the main feature that differentiates between the protostomians and the deuterostomians. Okay, and this is a division. So remember, we have kingdom, subkingdom, parazoa and metazoa. We have 2 grades, radiata and bilateria. In bilateria, we have 2 divisions, protostomia and deuterostomia. Okay, so here the blastopore forms the mouth, and here the blastopore forms the anus. This is one difference. Okay, that is the first difference. Now the second one, because we are looking at the developmental embryo, we can also say that here the cleavage is spiral and determinate. Here it is radial and indeterminate. Remember that we are classifying based on certain characteristic features, right? So here we are trying to explain the different characteristic features by which we are actually classifying these two into 2 different divisions, protostomia and deuterostomia. The first one is that here in this, the blastopore forms the mouth, and here in this, the blastopore forms the anus. And secondarily, the mouth forms at the upper end of the anus, here in deuterostomia. And when it comes to cleavage, the developmental embryo stage, the cleavage is a spiral and determinate. The angle is not 90 degrees. If this is it, the cleavage is lightly tilted, or at an angle. The second division occurs at an angle in the protostomia. So it is called a spiral cleavage. It is also called determinate because each unit will develop into a specific organ. So it is already determined at this stage that this particular unit will develop into this particular organ. But in radial symmetry, it is 90 degrees. The cleavage is at 90 degrees, and indeterminate because each unit is not responsible for the specific organ. They have not started differentiating yet. That means here in this, these embryos are called, the third one is, these embryos are called mosaic, and these are called reticulate embryos. Now, what is the difference between these two? This mosaic embryo, it is called a mosaic embryo because here we have seen this at the differentiation stage. If you lose this unit here at this stage, you will lose that organ. You will have this organ missing when it actually develops. But here in radial and indeterminate cleavage, even if this goes missing, because they haven't started differentiating it in a reticulate embryo, we have a fully formed individual with no deformities. These are the three main differences that you see between protostomia and deuterostomia. The first one is that the blastocore forms a mouth in this, and the blastocore forms a anus in this one, and the cleavage. We usually don't call these the divisions. We're not talking about the taxonomic unit here. The cells that divide, the first ones before forming the embryo, these are called cleavages. Rather than calling them divisions, we call them cleavages. So the cleavage is spiral and determinate here, and radial and indeterminate in deuterostomia. Spiral is they divide at an angle, radial is they divide at 90 degrees, and determinate means each unit is already predetermined to produce a particular organ. Here it is not predetermined, they haven't differentiated yet, so it's called radial indeterminate, and here it is called spiral determinate. And the embryo here is called a mosaic embryo, and an embryo here it is called a reticulate embryo. If you want to see a picture, let's see if I have one. We don't have it. Oh well, let's go back. Protostomy. We have here is the blastopore, and here is the blastophore. For the protostomes, this one becomes the mouth, and for deuterostomes, this one becomes the anus. Okay. And these the cleavage, as we have seen before, this is at an angle and this is at 90 degrees, and as we have already seen, this forms the anus and this forms the mouth in the protostomes and the deuterostomes. This is the difference between those two. Now let's come back to, where did we end? Oof. All right. So division, right? Protostomia and deuterostomia. Now the deuterostomia, the protostomia, this is the division, right? The division also has 3 subdivisions. Now here we have subdivisions. What are all the different taxa that we are looking at? Remember, we are started off with kingdom, Animalia, subkingdom, Parazoa and Eumetazoa. Then comes grades, which are Radiata and Bilateria. Then come division, Protostomia and Deuterostomia. Now the division also has subdivisions in it. So the Protostomia has 3 divisions. They are acylometa, or let's pick. One is acylometa, pseudocylometa, schizocylometa. And in deuterostomia, we have only one subdivision. It is called enterocylometa. Okay. Let's see. We have seen the characteristic features of protostomia and deuterostomia. This is at the taxon level of division. This division, the protostomia, has subdivisions: acylometa, pseudocylometa, and schizocylometa. A means it is not having. Coelo means body cavity. Eta means having. Acoelomata means it doesn't have a body cavity. No coelom. A pseudocoelomate has a false coelom, and schizocoelomate has a true coelom. These are the three differences. And the phylum that comes in here is a Platyhelminthes, Nematoda, and here the phylums we see are Annelida, Arthropoda, and Mollusca. And here in the Enterocoelomata we see Echinodermata. These are the phylums. That is the next division, right? From the subdivisions we get divisions, phylum. Echinodermata, Chordata, and Chordata. And we are in this, right? Okay. So the divisions, the Protostomia and Deuterostomia have subdivisions. The subdivisions are acoelomata, pseudocoelomata, and schizocoelomata. Now, what is a coelom? Coelom is a body cavity. Now, a true coelom, we call a coelom because here we have false coelom, we have no coelom, and by the time we come to the third one, it comes into a true coelom. What do we call a true coelom? True coelom is one where the body cavity is lined by mesoderm. So here in schizocoelomate, because here in acoelomata we have no coelom. Okay, this is occupied by mesenchyme between the ectoderm and the endoderm. In pseudocoelomate, this is a false coelom. The primary body cavity, which is a blastocele, develops into a pseudocoelom. That means it is not lined by mesoderm on both sides. Now, coelom is, let's say this is the gut, right? Your alimentary canal coming from mouth to anus. So if we cut it, let's say here we cut. This is the gut. And this is the body wall. So this space between them, this is lined by mesodermal layer. When this mesoderm layer splits into two, parietal and basal. When this splits into two and giving the cavity, so this is lined by a mesoderm. That is when we call it a true coelom. And these schizocoelomates from Annelida to Mollusca, I mean these animals have a true coelom. Understand the concept of coelom. Coelom is the cavity present between the gut and the body wall. Right? There are some muscles, organs present in there, but that is the cavity that is which we call coelom. A true coelom is one where it is lined by a mesoderm. Okay, so what's the difference? Here in the acoelomata, we know that it doesn't have a coelom. In Platyhelminthes, there is no coelom. We see in between the gut and the body wall, there is mesenchyme present. In pseudocoelomate, the blastocele from the embryonic stages develops into a pseudocele. Pseudo means false. It is a false coelom because it is not lined by a mesoderm. When we come to schizocoelomata, this is a true coelom because this mesoderm splits into two. So that means your coelom is actually lined by the mesoderm on the outside and the inside, between the gut and the body wall. Now, what's the difference between schizocoelomate and the enterocoelomate? This also has the Echinodermata, Hemichordate, and Chordates. These also have a true coelom. So this schizocoelomate and the enterocoelomates together are called eucoelomates. I know there are so many new words here, but try to follow. The subdivisions in protostomia are acylometa, pseudocylometa, and schizocylometa. The subdivision in deuterostomia is only one, which is enterocylometa. The phylum that are included are in acylometa we see platyhelminthes, in pseudocylometa we see nematohelminthes, and in schizocylometa we see Annelida arthropoda and mollusca. In enterocylometa what do you call that? So, the true coelom is a coelom or the body cavity that is lined by mesoderm. And there's one main difference between the schizocoelomates and the enterocoelomates. Let's see what that is. We have seen this before. So, it is at the level of formation of the coelom. In the protozoans, you see these two, these red colored ones, the coeloms, these develop into the coelom in protostomes, but in deuterostomes, you see these two pouches coming out of the gut. That becomes the coelom in deuterostomes. So that is the main difference. We call it schizocilus and enterocilus. These both are true coeloms, but there is a difference in the way they form, in the formation of the coelom. This is by the splitting of the mesoderm, and this is by the pouches that come out of the archendron. Okay. So with that, we come to the end